The final topic for rational functions is going to be holes in graphs. A hole will occur in a graph when a factor in the numerator and a factor in the denominator cancel each other. So, oftentimes what will be helpful is to go ahead and factor your numerator. So we get x plus 3 times x minus 3. Oh, we have a typo in this problem. This should just be x minus 3. So we have x plus 3 times x minus 3 over x minus 3. And then what you can see is that you have this x minus 3 cancels. So we're going to have a hole where x minus 3 equals 0. So we have a hole where x equals 3. And I'm going to show you how to figure out that ordered pair here in a second. So it's going to be at 3 something. When we cancel out that x minus 3, that leaves us with the function f of x equals x plus 3. So what we're going to do is we're going to graph this function like normal, except we have to account for this hole. So the hole is going to happen if we substitute in 3 in the new equation. We'll get f of x, or y, equals 3 plus 3, so y equals 6. So there's a hole at 3, 6. Otherwise, this function is going to be the graph of a line with a y-intercept at 3 and a slope of 1. So I can graph this like a normal line, except at the ordered pair 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, there is a hole. So otherwise, this is a perfectly normal line. It just has a hole at 3, 6. Here's a more complicated one. We have f of x equals x squared plus 2x plus 8 over 2x squared plus 2x minus 12. So let's start by factoring this. So we have x plus 4 times x minus 2. In the denominator, we can factor a 2 out, so that'll be x squared plus x minus 6. So we got 2 times x plus 3 times x minus 2. Now you notice that we have a common factor, so we're going to cancel this out, and that leaves us with a hole. And the x value is at x equals 2. So the hole is going to be at 2 something. We'll rewrite our function. F of x equals x plus 4 over 2 times x plus 3, or we could write it x plus 4 over 2x plus 6, whichever way you feel more comfortable. And we can substitute that x value back in, so we get y equals 2 plus 4 over 2 times 2 plus 6. So the y value will be 6 over 4 plus 6 is 10. So 6 over 10 will be 3/5. So the ordered pair is at 2 3/5 for the whole. So let's graph that on here. At 2, 3/5, we have a hole. And then we'll go ahead and graph this rational function like we were before. So we want to find vertical asymptotes by setting the denominator equal to 0. 2x plus 6 equals 0. So 2x equals negative 6. So x equals negative 3 is our vertical asymptote. 1, 2, 3. That means the domain of this function will be from negative infinity to negative 3. Skip over negative 3 and go to infinity. Our next step was going to be the horizontal asymptote. Horizontal asymptote, we have the degree of the numerator, and we're going to take this from the simplified function. The degree of the numerator is 1, degree of the denominator is 1. Those are equal. So I'm going to have a horizontal asymptote at y equals the leading coefficient of the numerator, 1, over the leading coefficient of the denominator, 2. So y equals 1/2. Which is going to be slightly below our hole, which was at 3/5. After the horizontal asymptote, we wanted to find x-intercepts. X-intercepts are found by setting the numerator equal to 0. So x plus 4 equals 0. So x equals -4. So we have an x-intercept at -4, 0 right here. Now we don't have very much to go on right now, so we do want to create an XY chart. And I'll go ahead and make 2 of those since I have 2 separate sections. And then it's easiest to create your XY chart using your simplified function. So we'll go y equals, that is going to be x plus 4 in parentheses divided by 2x plus 6 also in parentheses. Oop, left one out. Make sure you get those parentheses in there. Then we'll go to the table. Let's start on this section over here. I already have a point at -4. Let's try a point at maybe -6. -6 is 0.3. 0.3. Let's try at -3.5. -3.5 is at -0.1. How about let's try at -3.1, getting closer and closer to that asymptote. At -3.1, my point is at -4.5. So -3.1, -1, 2, 3, 4.5. Okay. So we have a pretty good idea of what's going on in this section. Since it can't cross this vertical asymptote, I can tell it's going to go along that horizontal one and then zoom down on that side of the vertical asymptote. Now let's pick some x values over in this section. We have our vertical asymptote at -3, so let's try -2.9. -2.9, -2.9 gives us 5.5. So we gotta go 1, 2, 3, 4, 5.5. Let's try at -2, -2, 1, -2, 1. How about at 0? If I put 0 in for x, I get 0.7, 0.7. And I already have this hole here, so I can connect these dots and see that my graph is going to ride along this asymptote with a hole in it right there. Now, if you really want to confirm your graph, what you can do is go back to y equals and type in the original. So in parentheses, x squared plus 2x minus 8, and then the denominator in parentheses, 2x squared plus 2x minus 12. And then we can look at the graph. The graphing calculator doesn't do a great job with rational functions. You can see that it's got that asymptote there showing up. Let's see if we can fix that a little bit. No, that's not going to work for me. So we're just going to be stuck with what we've got here and just imagine what's going on. This part of our graph shows up nicely. If we were to trace along here, when we get to x equals 2, which was our hole, it would not show up. If I did second calculate value and I put 2 in for x, it would not give me a value. If I go to my table and put 2 in for x, it will tell me error, and that's because I have a hole at x equals 2. It would also give me an error at -3 because that's where I had a vertical asymptote. So you can see your graphing calculator is not great to rely on for graphs, but it does help you incredibly on your XY charts. Just remember, when you find a hole, that you take your x value and plug it into the simplified equation to get the y value so that you can plot it on your graph.